Hi, my name is Jagruti Kanjia, and I am from the Advanced Analytics Division at SAS. In this session, we will see how you can incorporate Python into SAS Visual Data Mining and Machine Learning pipeline in Model Studio. There are many benefits of using Python with SAS Visual Data Mining and Machine Learning. For example, it makes interacting with SAS Viya easier for non-traditional SAS programmers within Model Studio. This pipeline shows how you can integrate open source technology within VDMML. You can use the open source code node to do data preparation and model building using Python. You can use Python SWAT with SAS code node to build deep learning models using packages like DLPY and compare them with traditional data mining and machine learning models. Our paper, Using Python with Model Studio for SAS Visual Data Mining and Machine Learning, provides more details and examples on using open source code node and using DLPY packages from SAS code node. The open source code node requires Python and necessary packages to be installed on the same machine as the compute server for SAS Viya. What if you want to use desired Python environment which is set up on a remote system? In this demo, we will focus on how you can use Python in an existing open source environment from SAS Visual Data Mining and Machine Learning to authenticate and transfer data to and from native Python structure. We will discuss how you can use your preferred Python environment for either data preparation or model building and call it through SAS code node for use or assessment within a pipeline. You can use SAS code node to run a Python script on a remote server and use SWAT to connect to an existing CAS session to access the data, run a Python modeling package, and upload the resulting tables into CAS and transfer files to SAS Viya system. To implement this, we will use Remrunner and Paramiko packages. In this case, Remrunner and Paramiko packages need to be installed in Python environments set up on a remote system where SAS compute server is running. The Remrunner, which is remote runner package, enables user to transfer a local script file to a remote host and execute it. The file is copied to temporary location on a remote host, permissions are set to 700, and script is then executed. Current limitation of Remrunner package is it assumes that SSH keys, which allows passwordless logins, are already in place. There is no option to provide a password in a code. To implement this, we created this pipeline in VDMML project in Model Studio. The SAS code node is used as a supervised learning node. In this example, the SAS code node is used to create and submit Python file to remote system and display results from executing the Python model. The feature machine node is used to generate new features by performing variable transformation to improve data quality and improve model accuracy. The new features are generated to fix the data quality issues like high cardinality, high cardiosis, high skewness, low entropy, outliers, and missing values. The CAS procedure is used to create a Python file named gbstat.py, which, when executed, will run an extreme gradient boosting algorithm. This algorithm is an implementation of gradient boosted decision tree designed for speed and performance. Here we are importing the required packages. These packages need to be installed on a remote Python environment. We use SWAT to create a connection to CAS Server and upload the data, XGBoost to build extreme gradient boosting model, matplotlib to create the reports, and Paramico package to transfer necessary files. If your CAS server is configured to use TLS for communication, you must configure your certificate on the client side. Note that beginning SAS Viya 3.3, encrypted communication is enabled in the server by default. If you don't configure certificate on client, you will receive error when you try to connect CAS server from Python with SWAT. This error can be alleviated by setting the path to correct certificate in the CAS client SSL CA list environment variable in the environment where you are running Python. The path indicated here is a client-side path, so the certificates are typically copied to the local directory from SAS Viya system. To enable a Python program to work with SAS Cloud Analytics Service, you must establish a connection to CAS Server. The SWAT package, that is the SAS Scripting Wrapper for Analytic Transfer package, that's simply referred as a SWAT, is a Python interface to SAS Cloud Analytics Service. It allows users to execute CAS actions and process the results all from Python. In fact, the SWAT package mimics much of the API of the Pandas package so that using a CAS should feel familiar to current Pandas user. We are using swat.cas class to create a connection to CAS server running on SAS Viya system. You must have an auth.info file so that you can specify your credential to controller. The DM_CAS host and DM_CAS port macro variable are initialized to point to CAS server used by Model Studio. The DM_CAS session ID macro variable resolves to CAS session associated with the CAS SAS code node. The SAS code node editor provides this various macro and macro variables, which makes it easy for user to write efficient code. The easiest way to get data from CAS is using the data loading method to_frame. This is similar to Pandas method like read CSV. The only difference is that the method operates on a CAS table object rather than Pandas data frame. Here, the data frame DM_input_df is created from the entire input table in CAS. Create a data frame called x_train with input variable and series called y_train containing the target variable for training observations. Similarly, x_valid and y_valid are created for the validation data. We also create an evaluation set, eval_set, containing the training and validation data. We create and fit extreme gradient boosting classifier model to our training data set. We use the eval_metric option because we want to generate the plot of several metrics, for example, error and log loss at each iteration for our evaluation set. We would like to create an output file and display in SAS code node results. Python includes the built-in file type. Files can be opened by using file types constructor. Open output.txt file for writing and print XGB model to the output.txt file. We will transfer this file to SAS Viya system to display in a results window. You can make predictions by using the fit model on the complete data set. To make predictions, we use a function predict_proba. You can add two new posterior variables created by using the predict_proba to DM_score df data frame. The dm underscore score df data frame is copy of dm underscore input df data frame. The I underscore variable, the classification variable, is created using predict and added to dm underscore score df data frame. We use the plot tree function provided by XGBoost to create and display the tree plot. It is important to change the size of the plot because the default size may not be legible. The numTree option indicates which of the generated trees should be drawn, not the number of trees. Here we set the value to 3 to get the third tree generated by XL gradient boosting model. We save the current figure to rpt_tree.png file and specify the resolution in dot per inch while saving the image file. A trained XGBoost model automatically calculates feature importance on your predictive modeling problem. This importance score are available in feature underscore importance underscore member variable of train model. We are creating new data frame called var_imp, which contains the variable name and importance score of the variable. Here we upload the updated dm underscore score df data frame to CAS running on SAS Viya system and convert it into a CAS table. We used upload underscore frame method to upload data file to project CAS lib and node ID underscore score dataset. This is the name of a score table that Model Studio expects, and it will use it to generate model assessment reports. We also want to upload relative importance of score generated by XGBoost model to CAS in a project library as gb underscore var_imp table using upload frame method. In order to take advantage of some of the reporting capability of Model Studio, we convert the evaluation results to our evaluation set to a data frame called stat. We upload and convert the data frame to create the gb underscore stat CAS table. This table contains 4 columns, the log loss and error for both the training and validation data at each iteration. In order to transfer the output.txt and rpt_tree.png files to SAS Viya system from the remote system where Python is running, we use Python Paramico package. The Python Paramico gives an abstraction of SSH v2 protocol with both the client-side and server-side functionality. As a client, you can authenticate yourself using a password or key, and as a server, you can decide which users are allowed access. An instance of paramico.ssh client can be used to make a connection to remote server and transfer files. Paramico requires that you validate your trust with the machine. This validation is handled by calling set_missing_host_key_policy method on the SSH client and passing policy you want to implement it when accessing new remote machine. The file transfers are handled by the Paramico SFTP client, which you get from calling open_SFTP on an instance of Paramico SSH client. Use the put method to upload the file from Python system to SAS Viya system. Now, we run proc_cas to create a file that contains Remrunner code, which will run in Python environment set up where compute server is running in SAS Viya system. The Remrunner, remote runner, transfers gb01.py file to remote host where Python is running and execute it. In this case, gb01.py file copied to temp location on the remote host, permissions are set to 700 and script is then executed. On cleanup, the PID directory and all contents are removed before closing the connection. Finally, we create custom reports that display tree plot and output files created on remote Python system. We will also generate report to display feature importance table generated by XGBoost model. The DM-CAS report macro is used to register and describe tree plot image, Python output file, and feature importance table. Sometimes images and plots generated in Python and displayed in Model Studio can have a readability issue because of resolution. We now create a report such that we can display either of our calculated metrics for the training and validation data. We obtain the gbstat datasets from CAS CB_state table by adding the iteration number and modifying the structure of the table so we can plot it. The new variable data rules identifies if statistic is training or validation value. The log loss and error variable contains the metric value corresponding to the iteration and the data role. The DM-CAS_report macro gives users the ability to create more interactive reports than just the images and tables. Here we add the custom XGB Iteration Plot report to the results window of the SAS code node. This report will be a line plot of either the log loss or error metrics by iteration for both partition data. The view option is used to indicate that we want to be able to select displayed metrics. When VDMNL pipeline is executed, SAS code node creates two Python scripts, GB01 and script containing Remrunner code during execution. The script containing Remrunner code was submitted to Python environment running on the SAS Viya system using base SAS Java object. The Remrunner code transferred gb01.py file on remote system and submitted to Python environment running on that system. The SWAT was used on a remote Python system to connect to existing CAS session running on SAS Viya system to access the data. The input table is downloaded from CAS to Python and data frame is created. The Python modeling package executed on a remote system to build XGBoost model. The score table, variable importance table were uploaded to CAS from remote Python system using SWAT. The output.php and tree.png files were transferred to SAS Viya system, copied to node directory using Paramiko package. The Node tab displays tree plot, Python output file, and feature importance table. The XGB Iteration Plot report also appears in the Node Results tab. The selector enables us to control if the log loss or error should be displayed. The assessment report results are calculated from the uploaded score table. The lift report, ROC report, FIS statistic table, and event classification chart is created and displayed in the assessment tab. So here we saw how using a SAS code node, you can run a Python script on a remote server and use a SWAT to connect to an existing CAS session to access the data, run Python modeling package, and upload resulting tables in CAS. We also saw how using the SSH client, user can transfer files from the remote server to the SAS Viya system to display reports in SAS Code Node Results window. If you need more information, you can refer to this paper using Python with Model Studio for SAS visual data mining and machine learning. You can find sample code in GitHub. Please contact us if you have any question or need more information. Thank you.